Welcome. I'm Kutsayamandi Teresa, and I'll be your host and guide as we take a look at how to build IoT apps in C# on a Raspberry Pi with Windows 10 IoT Core. So if you're not familiar with the Raspberry Pi, this is the Raspberry Pi. It is a full single board computer with system on chip. It comes with inbuilt HDMI port for video output. It has got the stereo output. It has got 4 USB ports and built-in networking with the Ethernet. So the default operating system for this Raspberry Pi is the Linux, although you can run other operating systems like the Windows 10 IoT Core. So in this particular demo, I'm going to be using the Raspberry Pi 3. So this one here comes with inbuilt Wi-Fi and Bluetooth, and it also runs on the ARM V8 64-bit core processor, which makes it perfect to build some quite powerful IoT gadgets. So in this video, I'm going to show you how to download and install Windows 10 IoT Core onto the Raspberry Pi. I'm going to show you how to wire up an LED to the general purpose input-output pin of the Raspberry Pi, and I'm also going to show you how to build a C# application on the Universal Windows platform. So by the end of this video, you should be able to properly set up your toolchain to build some more complex projects with the Raspberry Pi. So with that said, let's get started. So Windows 10 IoT Core is a version of Windows designed specifically for IoT scenarios. It's a version of Windows without the desktop and the shell components. So what we have is a situation whereby we have got a single app that is owning the whole user interface and experience. So the UI itself can be designed in XAML or HTML, depending on which one you prefer to use. So now, since we don't have the desktop experience, we do not have the dialog to actually configure the Wi-Fi and Bluetooth as you do on your normal PC. Instead, what we have is a web server, which I'll show you in a couple of minutes. So what I'm going to do right now is I'll head over to my browser and show you how to install and set up the Windows 10 IoT Core. So I'll go on to Windows on devices. Right, so this would actually resolve to a web portal where you'll be able to download the Windows 10 IoT Core. So as you can see here is a bunch of information on the Windows 10 IoT Core. So if you click on the Get Started, right, it will actually give you a web page where you there's some steps that you need to follow. So it actually makes it easy for you. So what I'm going to do here, I'm going to select Raspberry Pi 3, and then step number 2, select your installation media. I'm going to select the installation onto my blank SD card. Okay, and then here I'm going to select the Windows 10 IoT Core version, and then I'm going to click next. Right, and then here on step 2, it actually gives you an option of downloading the dashboard. So the dashboard, this is the actual application that you're going to download onto your computer. This application is the one that is going to download the Windows 10 IoT Core for you. It will unpack the image and then it will flash it onto your SD card. But I'm not gonna download it now because I already have it installed on my machine. What I'm gonna do instead, I'm gonna start it up here. Okay, I'm gonna click run. So now, as soon as your download finishes, what you're going to get is this interface. It will take you right to where it says set up a new device. As you can see here, there's first let's get Windows IoT Core on your device. What you need to do now is you need to select your device type on this combo box here, and then as you can see, there's it's actually compatible with more than one device. It's compatible with the Minoboard Max and the Qualcomm Dragon board as well. So we're gonna select the Raspberry Pi 2 and 3 option, and then the build is the only one, the Windows 10 IoT Core. And then what you need to do is to insert an SD card onto your computer. Now as soon as you insert the SD card, this IoT dashboard would automatically detect it, and then it will list it for you there, and then you'll be able to select it. And then after that, you give your device a name. Mine is called my Raspberry, and then you give it a username and a password. And then after that, you just click accept and then download and install. So this process takes about 15 minutes. I'm not going to do that because I already have the Windows 10 IoT Core installed on my SD card. So right now I'm going to show you how to set up the device. Okay, I hope you've successfully installed Windows 10 IoT Core onto your SD card. If you need more information, you can always go onto the Windows on Devices website. There you will get more information regarding the type of SD card and the size that is recommended. So now that you've got your SD card loaded with the Windows 10 IoT Core, you can remove it from the computer and insert it onto the SD card slot of your Raspberry Pi. And then you can put up and make sure you're connected on the same network with your computer. And if you're not connecting via a router, you obviously have to do some configurations on your IP settings. So I've got mine. What I'm going to do is I'm going to put it up. So if you go onto my devices there, and then you put up your Raspberry Pi. Right, it will take quite a few seconds, and then it will show up on your My Devices list. There you go. So if you've got more than one device, you have all of them showing up on the My Devices list. So as you can see there, that's my Raspberry Pi. The name is my Raspberry, and its IP address is 192.168.0.2. So what I'm going to do right now is I'm going to click on this configure, right? And then as you can see here, it gives me an option to actually open the device portal in a browser. So if I click that one, so what it does normally, it will ask for your username and the password, which is the default is administrator, and the password is the one that you just assigned it when creating the image. So this is the web server that I was referring to earlier, and then so you see here, if you can actually go onto my devices, you can see all the devices that are on your Raspberry Pi. We've got the remote sensor driver and etc. And then if you go onto the networking, you can actually see all the available networks to connect to. So this is your interface. This is your desktops per se. This is where you actually go on to install the apps to you can actually check the performance of the system, and you can play around with it and see many things regarding your Raspberry Pi. And the cool thing about this is this web server that we're looking at right now. You can actually get the code for this. You can actually get the code for this, so that you can actually develop your own app and put this as a function in your own app, where you're able to actually configure the Wi-Fi and the Bluetooth and stuff like that. Okay, so the hardware interface of the Raspberry Pi is what allows the Raspberry Pi to communicate with the outside world. Things like switching on an LED, running a motor, and actually reading signals that are coming from the outside world. So now this interface is exposed through a 40-pin header, and the functionality of these pins, they actually vary. Some pins are actually general purpose input output pins, otherwise known as GPIO. As you can see, these are the ones that are colored in orange. So we can use GPIO pins for any function of our choosing. We can actually determine what we want to use for those pins, and some pins actually serve more than one purpose. As you can see, some are GPIO pins, but at the same time they can be used as an interface. We've got SPI interface. We've also got the I2C interface. So for those of you not familiar with electronics, SPI is a high-speed 3-wire serial communication protocol that is primarily used in embedded systems for communicating in short distances. And I2C is a 2-wire serial communication also. This one was designed to allow communication between two components which reside on the same circuit board. Now I need to point out here that the pin numbering on the board does not necessarily match the GPIO pin number. For example, we have got the pin number 19 on the board is actually pin GPIO pin 10, and so whenever you're developing on the PI, you need to have this diagram handy. So in our case, we want to blink a single LED, so we need to choose a GPIO pin that we will connect our LED to. So in this case, we will use GPIO pin number 26, which is actually pin number 37 on the physical board. So yeah, now let's take a look at the actual board and wire up our LED. Okay, so what I've got here is I've got this breadboard here, and then I've got the resistor, the LED, and I've got some jumper cables here. So this LED, as you can see, it has got a longer leg and a shorter leg. So your current flows from the longer leg to your shorter leg. So what I'm going to do is I'm going to connect my LED onto the breadboard there, and the resistor, this one is the current limiting resistor to protect our LED. I'm going to connect that one there. Right, so one end of the resistor is connected to the longer leg of the LED, right, and then this jumper cable, this one I'm going to use to route a signal from the Raspberry Pi onto the breadboard. So this is the signal that actually switches our LED on and off by passing some current through it. So I'm going to connect one end of this jumper cable to on the same potential as the resistor, and then the other end I'm going to connect to the pin number 37. Remember, this is the physical pin number 37, which is actually our GPIO pin number 26. Right, now our setup is not complete because we need to have ground for our circuit to be complete. Now our ground is at pin number 39, the physical pin number 39, which is right next to our pin number 37, right? And then this one I'm going to connect it right here. So since this line is on the same potential, we actually have our shorter leg of the LED connected to ground. So now our setup like this is ready for us to download the application and start blinking an LED. So I think now it's time to head over to the computer and start showing some code. So the Universal Windows platform was introduced with Windows 10, and it provides a common platform available on every device running Windows 10. So this actually means that you can create a single app that can be installed onto a wide range of devices. So that includes your Raspberry Pi, your HoloLens, your Xbox, your tablet, phone, and desktop. And this is quite beneficial if you think of it, because what we have here is a programming model that is identical across all these devices, and at the same time there is this mechanism for expanding with the extensions, as I'll demonstrate shortly. Okay, so I think we can jump right in and start building our hello blinking. We're going to need a Visual Studio for this, so if you don't have Visual Studio, you can go to www.visualstudio.com, and here you can download Visual Studio Community Edition for free, which is it's a fully featured version. Now I already have Visual Studio installed on my machine here, so you can go ahead and download it and run it. What I'll do is I'll start Visual Studio from there. Now once you are installed Visual Studio, you can go to File, New Project, and then in the New Project dialog you can select Visual C#, Windows Universal, and then we're going to select the blank app, and then we can give it a name. We'll call it Hello Blinky. Right, you can click OK, and then OK. Okay, so now this blank app as it is right now, we can deploy it to different devices and it will run, but because we're developing for an IoT device, we need to expand on this app, as I mentioned earlier. So how do we do that? We do that by telling the Universal Windows platform that we'll be using special extensions for IoT. So you come to your references there, and then you right click and then add references, and then you go to your extensions, and then I'll pick Windows IoT extensions for the UWP. Don't just select it there, just make sure you check that box there, and then you can click OK, and then you can see that your extensions have been added to your references. Right now you can then go to your main page to C#. Right, so the first thing that you're going to need to do is to add the namespace for our extensions. So I'm going to put the using windows.devices.gpio. Right, and then after that we can add our constants. Now remember, our LED is connected to GPIO pin number 26, so this is the LED that we're referring to there, and then we can instantiate our pin. And then we need to create a function to initialize our GPIO pin. And the first thing we're going to need is a controller. So this is the controller that will give us the default GPIO pin on the device, meaning to say that if we're running this code on the Qualcomm Dragon board, we'll get whatever pins are default on that board, and if we're running it on the Pi, we'll also get the pins that are default on the Pi. But if we were to run it on a mobile phone, this will actually return a null because the phone doesn't have GPIO pins. So we need to take care of that. target device that does not have GPIO pins, and then we can proceed by opening the pin. And then we pass the LED. Now remember, this is a GPIO pin, so we can use it either to read signals from the physical world or to send a signal to the physical world. But we need to configure it as such, so that we are prepared on the board to electronically achieve that. So we can do that by actually setting this pin as an output. And then we can call the initialize function from the main page. Just copy this. Right, and then an embedded system, we've got what we call a super loop. So this is a loop that will execute forever. Since we want to blink an LED, we want to keep blinking it until we remove power from the board. Right, and then we can now writing a I. Right, and then we need to delay a second because we're going to be blinking in 1 second intervals. So we just save. Okay, now because we're using the async, this one needs to be needs to have an asynchronous qualifier, and then we also need to add the namespace for threading. Okay, and then I think we're good to go. Good to go now. We need to set up the board and power it up. Now, before we try to deploy our app onto the board, we need to make sure that we select the processor here. So you see it's S86. Now we need to select the ARM, right? And then we're deploying onto a device, so we need to specify the IP address of the device that we're deploying to. So we can say this one is a remote machine, and then we can specify the IP address. Here you can either specify the IP address, or you can actually give the actual name. Since I have got the Raspberry Pi, I will just put the name for the Raspberry Pi there. and then when all is good, we can then deploy to the remote machine. Okay, here we go, and our LED is blinking. Okay, so thanks for watching. I hope you enjoy coding and building your own IoT apps.